This lesson talks about radical equations. So the first thing that I'm going to start with is this word problem. By measuring a car's skid marks, investigators can determine how fast the car was traveling when the brakes were applied. On dry pavement, the speed in miles per hour is given by this equation, where d is the distance in feet that the car travels as it brakes to a complete stop. If a car is traveling 40 miles an hour, you can actually solve this equation, and you can determine the braking distance. Interestingly enough, if you measure the length of the skid mark, you can use this equation to determine whether or not the car was speeding. This is called a radical equation because there is a variable underneath the radical sign, and that's what we'll be talking about in this lesson. Solving radical equations is just like solving any other kind of equation. Really what you're trying to do is undo a particular process. Remember, a radical sign is similar to parentheses, so if you're doing order of operations backwards, it's one of the last things that you'll do. So taking a look at this equation, the first thing that we want to do is add 3 to both sides. Then we can square both sides. Now we solve it the way that we are used to. And in this case, t is equal to 5. We can take a look at this next problem. Here we've got a variable under the radical and outside of the radical, but we go through the same process. To undo a square root, we square. Now what we've got is a quadratic. And this is simple enough to FOIL. Okay, so trying the next one. Again, we've got some terms under a radical, and we have some things outside of the radical, so we're going to add x to both sides. And just like before, I'm going to square both sides. On the left, I get 9 times x plus 1. On the right, I need to remember to FOIL this. And then I move everything over to one side so that I can have a quadratic that's set equal to 0. And then this can be factored. X plus 1, x minus 8. So x is equal to -1 and positive 8. This next one is a bit of a tricky one, and it's actually one where a lot of you are going to make mistakes. So if I were you, I would watch this a couple of times. The thing that makes this one more of a challenge is that you have 2 radical signs separated by, here it's a subtraction, although it could also be addition. What you want is to have 1 radical sign on either side of the equal sign. From here, you will square both sides of the equal sign. And again, this is where the mistake will come. On the left, it's pretty easy. It's 2x minus 2. Mistakes will be made when you square the right-hand side. Remember, it's a squared, so that's just x plus 6, plus 2ab, so that's going to be 2 times the square root of x plus 6, plus b squared. So our next step is to isolate this radical term because we're going to have to square this one more time. So when I do that, I can bring over the x term, which gives me simply x, and then I've got -2 minus 6 minus 1. So that becomes minus 9. And on the right, I'm left with 2 times the square root of x plus 6. Now I square again. This becomes x squared minus 18x plus 81 is equal to 4 times x plus 6. Now I'm going to do a couple of steps at the same time. I'm going to distribute and move everything over to the left-hand side so that I have a quadratic that's set equal to 0. So x squared stays the same. I have negative 18x minus 4x, which is negative 22x. Now I've got 81 minus 24, and 81 minus 24 is 57. And that's set equal to 0. From here I factor, and I get x minus 3, x minus 19, which means that x is equal to either 3 or 19. Now in this case, which is a specific case, you have to check. And the reason is because you had to square this equation twice. So you can end up with extraneous roots. So you go back to your original up here, and you check to see if it works. So if I plug in 3, I get the square root of 6 minus 2 minus the square root of 3 plus 6, and I need that to equal 1. This ends up being the square root of 4 minus the square root of 9, so that's 2 minus 1, which is negative 1, and negative 1 does not equal positive 1. So 3 is an extraneous root. We do the same thing with 19. We take the square root of 2 times 19, that's 38, minus 2, minus the square root of 19 plus 6, because we need that to equal 1. This ends up giving me the square root of 36 minus the square root of 25. That's 6 minus 5. 6 minus 5 is 1. That checks out, so this answer is correct. The last problem we're really not going to think of as a radical equation because there is no variable under the radical. However, we do have a radical and we do have some variables. Something you need to think about is combining like terms. We have a 3x and an x root 5. These are actually the same like terms because they both have a variable of x in them. So in order to solve this, I'm going to move this over. So I end up with 3x minus x root 5 is equal to 2. Because then I can factor out the x and get 3 minus the square root of 5 is equal to 2. And now I can think of this as the coefficient of x. And the way that you isolate x is you divide by the coefficient. So x is now equal to 2 over 3 minus the square root of 5. And of course from here, we need to rationalize this denominator. We multiply by the conjugate. And here I get 9 minus 5 this cancels, and x is actually equal to 3 plus the square root of 5 over 2.